Welcome to Maths and Science by IITian channel. In this lecture on calculus for IIT JEE Mains and Advanced, I discuss a very important topic on residue theorem involving complex numbers calculus. Contour integration, it is called as integration involving complex numbers. It's a challenging proof. It will be useful for JEE Advanced, CSIR Mathematics, and also higher mathematics examinations. Why I have taken up this? Because in my short video, I have given you the value of E as pi by 2E is equal to integral of 0 to infinity cos x by 1 plus x square. Then I thought, let me prove it. Certain things out of way I will collect and I try to prove them so that you will get the grasp of the higher mathematics level questions which can be solved with ease. There is a theorem called residue theorem in complex calculus, that is in complex analysis, calculus involving complex functions, residue theorem. I will talk about the residue theorem and we apply that residue theorem, and we will talk about the contour integration, and we will arrive at the value of this integration as integral 0 to infinity cos x by 1 plus x square is equal to pi by 2e. This I have specifically taken up. It is a very good standard integral and it is better to know it whenever you come across any contour integration. Now, it looks very simple at the face value, but it's not that simple. We have to go through the complex analysis, complex algebra and contour integration, then only we will get the value. It may look like a general integration, it's not a general integration. It requires specific knowledge using the complex analysis, complex algebra and contour integration. Let's go for it. What is the question given here? Question is find or show that integral 0 to infinity cos x by 1 plus x square dx is equal to pi by 2e. At the face value it looks very simple, but it's not so. Let's move further. But however, by using the method of residue theorem, we will solve it in minutes very easily. But you should have the concept of contour integration and symmetric integrals. For odd functions and even functions. Now, let us apply these concepts, because concepts are more important rather than the question itself, and solve this question. Let us see solution. You know very well, any complex number z is equal to, I have explained about the complex numbers in my previous lectures. Please see them. Z is equal to x plus iy. In this, x is the real part, y is the imaginary part, iy is the imaginary part. And you should also know that This type of integrations I have done previously. Please refer to them. Any integration, for example, this type of integration 0 to infinity cos x by 1 plus x square dx is equal to it can be written as minus infinity to 0 cos x by 1 plus x square. This way also we can write. That implies integral minus infinity to plus infinity cos x by 1 plus x square dx is equal to 2 into integral 0 to infinity cos x by 1 plus x square dx. This implies integral 0 to infinity cos x by 1 plus x square dx is equal to integral minus infinity to plus infinity half into cos x by 1 plus x square dx. First you should understand this. From this, for example, let us take what is e to the power of ix? E to the power of ix is equal to cos x plus I into sin x. In this, what is the real value? Real value is cos x. Then in this, can I replace this cos x with real value of e to the power of ix? Definitely. Let us replace this. From these all this discussion, we get the equation integral 0 to infinity cos x by 1 plus x square dx is equal to half into integral minus infinity to plus infinity. In place of cos x, I will write real value of e to the power of ix by 1 plus x square dx. Which implies integral 0 to infinity cos x by 1 plus x square dx is equal to integral half into integral minus infinity to plus infinity. Let us write little bit. This way so that it will be easier. Half into real value of, you just see here, real value of e to the power of ix by 1 plus x square dx minus infinity to plus infinity. This is what we have got here. Now, x square plus 1 is equal to 0. This implies x is equal to minus 1 to the power of half plus or minus, that is equal to plus or minus I. Why? Since square root of minus 1 is equal to I. Are you able to follow till this time? That means when x is equal to plus or minus I, the denominator vanishes in this equation. Denominator will become 0. Hence this particular equation will not be particular this function. Let us say function x. This function will not be defined when x is equal to plus or minus I. At this point, we can find out. I have explained in my previous classes, if you see this is the function x. Let us try to understand the concept. At one particular point x is equal to plus or minus I, plus I or minus I, this particular function is not defined because denominator is becoming 0. Hence, at some point in and around it, it is defined. Plus or minus I plus or plus or minus I minus, it is defined. But exactly at plus or minus I, it is not defined. Then that surrounding values, it is defined, surrounding values. At this particular point, it is not defined. And what is the residue left over? When the surroundings try to become, x try to become plus or minus I, there will be some residue left over. That residue, you please see, that residue of any function at a point I, because it is plus or minus I, we can take I on the upper half plane. Residue at I plus I, let us take limit x tends to I. I am simplifying the theorem actually. I should not say like this, but I am saying it for the benefit of you, for the benefit of all of you. E to the power of ix by x plus I into x minus I. This is the residue. Please remember, as per the residue theorem, the residue is, what is the residue value? Residue value, when denominator becomes 0, residue value of function at I, this is in complex calculus. It is a complex calculus. In contour integrals, it is limit x. Let us say when you are dealing with complex numbers, let us say it is z. Z tends to I. This x don't compare with the z is equal to x plus y. It doesn't have any relation. This x I have written only for your convenience. Actually, the exact formula is limit z tends to I, z minus I, because we are doing it at I, that is the point where this particular function becomes 0, tends to 0, the denominator of the function tends to 0, the function value where the function is not defined when denominator tends to 0. The denominator value in the function tends to 0, that is z tends to I. z minus I into function z. This is the equation for this particular problem. Here, what is this value? You calculate. Limit z tends to I, z minus I into e to the power of iz by z minus I into z plus I. Because 1 plus z square is equal to z minus I into z plus I. Then it will be z minus I here and z minus I here will go away. What will be its value? Limit z tends to I e to the power of iz by z plus I. That is equal to, as z tends to I, we'll replace z with I e to the power of I into I whole divided by I plus I. That is equal to e to the power of I square by 2I. What is e to the power of I square? I square is minus 1. E to the power of minus 1 by 2I. That means residual of for this function I is equal to 1 by 2ei. Once you know the residue, here we apply the residue theorem. As per residue theorem, once residue is known, you write this equation carefully. The value of contour integral, this is called as the contour integral of any function dz is equal to 2 pi I into residue of for any function fi. This is the equation. From this we will get the value of integral directly. Contour integral value. Now, hence contour means it is starting from some place and ending at the same place. That means minus r to r. There is a circle. You are starting here. And we have taken, this is minus r, this is plus r. Here we have taken the first half, upper half. When you take the upper half, this value will be integral minus r to r. As function x dx is equal to minus r to r function x dx is equal to limit r tends to infinity. Let this radius of the circle be tends to infinity. This value will be, what is the value? This value will be pi by e, which implies minus infinity to plus infinity Why it is pi by e? Because of this formula. Because integral contour is equal to 2 pi I into residual. What is the residual of function I? Residual of function I is equal to 1 by 2 ei. 2 pi I into 1 by 2 ei. I gets cancelled. 2 gets cancelled, and this value will be pi by e. Please understand this. Minus r is tending to infinity, that I am taking a circle of infinite radius. R tending to infinity, that means minus r to r is minus infinity to plus infinity. Function x is, what is function x? E to the power of, sorry, I will write in black ink, e to the power of ix by 1 plus x square dx is equal to pi by e, which implies integral 0 to infinity e to the power of ix by 1 plus x square dx is equal to pi by 2e, because half of this, when you have taken minus infinity to plus infinity some value, 0 to infinity it will become half, pi by 2e. Now, what we have seen here, integral e to the power of ix by 1 plus x square is pi by 2e, 0 to infinity. Or we can even write it as e to the power of ix by 1 plus x square is nothing but, we can write it as the real part of e to the power of ix by 1 plus x square dx is equal to minus infinity to plus infinity. This can be written as integral minus infinity to plus infinity when you take real part, taking real part, e to the power of ix by 1 plus x square dx is equal to pi by a. By taking real part, it implies integral minus infinity to plus infinity cos x by 1 plus x square dx is equal to pi by a. That implies integral minus infinity to plus infinity cos x by 1 plus x square dx is equal to pi by a. That implies integral 0 to infinity cos x by 1 plus x square dx is equal to pi by 2a. You see how much easily we have got the value. First is that I will explain, I have explained in detail this, I will explain in short how to do it in the examinations like JEE Advanced or CSIR Mathematics. First, 0 to infinity, you convert into a function integration as minus infinity to plus infinity, that is twice of the 0 to infinity value. Then you take the real value, cos x is the real value of e to the power of ix, replace cos x by e to the power of ix, real value, and minus infinity to plus infinity, you calculate the value. When you go for it and find out the residue, in this e to the power of ix by 1 plus x square, 1 plus x square is equal to 0, x is equal to plus or minus I, will take plus I and will x minus I will discard by multiplying, finding 1 plus x square is equal to x plus I into x minus I, and at I tends to, x tends to I, this x minus I will get cancelled and the answer will be e to the power of ix by 2i, e to the power of iz by z plus I, and it will be 1 by 2ei, which you can very well do in limits, which you have learnt in limits. Once you have got the value from the limits, it is as a residue, then residue theorem is the most important theorem, where integral of contour function z dz is equal to 2 pi into residue of pi. By taking the value at I, we have considered only upper half. Then as r tends to infinity, minus r to plus r, because we have taken only upper half. Minus r to plus r, it is pi by e. That how pi by e has got? Any contour integral fz dz is equal to 2 pi a into residue of pi. That is 2 pi I into 1 by 2 ei. I get cancelled, 2 gets cancelled, and that will be pi by a. Minus infinity to plus infinity, e to the power of ix by 1 plus x square dx is equal to pi a. This value we have got. From this value, by taking the real value, real part only, we can deduce that minus infinity to plus infinity cos x by 1 plus x square dx is equal to pi by a. Then my integral minus infinity to plus infinity cos x by 1 plus x square dx is equal to pi by a. Half of that will be for 0 to infinity. What we have to find out is 0 to infinity. This is how we have to solve it. And with this, I want to conclude this lecture. Best of luck to everybody. Thank you for listening to me. In this, we have developed the concept of residue theorem, complex integration, contour integration, and it's an excellent tool for solving many important problems in integration which cannot be solved in proper integration processes. This residue theorem, I will give another one more example so that you will understand better in the next class. So this will be a very important tool and a very powerful tool to do the integration. Otherwise, integration, definite integral will become complicated otherwise. This is a very good example. Best of luck to everybody. Thank you for listening to me. If you feel you have added some value addition is there for you because of this lecture, kindly share and share my video, hype this video and subscribe to my channel. Maths and Science by IITian. This type of powerful tools in between I will be giving you so that you can use them in your examinations at advanced level. Thank you for listening to me. Best of luck. Thank you for seeing my lecture.